All right, 5.6 inequalities in two triangles and indirect proof. Don't be feared, or don't fear that indirect proof. Is very simple. This section is very quick, so we'll make it short and sweet. Yesterday we talked about making sizes, or determining the sides of a triangle, which one's bigger, which one's smaller, put them in order least to greatest. Put them in order from least to greatest. Determining which angles are bigger, stuff like that. You know, finding that range of numbers. We're going to kind of touch on that same thing. We're going to deal with the hinge theorem. I'm not going to go over exactly the whole deal with the door hinges and all that. Just it'll probably confuse more of you than it'll help you. The hinge theorem basically says if two sides of a triangle are congruent to two sides of another triangle. Okay, not two congruent triangles. That's not what this is saying. In fact, these are not going to be congruent triangles. Keep that in mind. But basically, AB here is congruent to BA. BC is congruent to AD, okay? So since those two sides are congruent, then we're going to start looking at the included angle. Here is the included angle. That's the angle in between the two sides. Here's the included angle here. That's the angle in between the two sides. Notice that this angle is bigger than this one. That means that side BD is going to be bigger than side AC, right? Because essentially, this side are going to be the same. It's still got to be equal to 180. So since this side is smaller, this angle's smaller, this side's going to be smaller. Angle's bigger, this side's going to be bigger. That's what makes them not to be congruent triangles. So let's look at it again. So you might have something like this. AC, that's this side here, is less than BD because angle B is less than angle A. So maybe just a little bit off. You know, here's 8 and here's 9, right? Okay, so that's going to be the case for all of them. Okay, if you have any questions, as always, write down your question and bring it to me in class or tutoring. Okay. All right, so let's look at this another way. Here, we have this side is congruent. Sorry, this side right here is congruent to this side. That's by our congruent markings. We know that this side here, this side here is congruent to itself because of reflexive. So now we have two congruent sides on two different triangles. Now let's look at the included angles. This angle 42 is bigger than this angle 40. So that means that BC must be greater than AB because the angle here is bigger than the angle here. Okay? So BC is greater than AB. Now again, it's not side angle side, right? Because the angles are not congruent. Remember, these are not congruent triangles. Okay? Let's look over here now. Now, we have this side being congruent to this side. Those 12s are congruent. This side's clearly congruent to itself because of reflexive property. But now I have two unknown angle measures. I don't know what the measure of angle 1 is. I don't know what the measure of angle 2 is. If that's the case, I need to at least know the third side. So now I know that this side and this side are not congruent, making these triangles not congruent. Otherwise, if they were the same, they would be two congruent triangles using the side theorem. But since they are not the same, I can now make a conjecture about these two angles. Since this is congruent to this, and these are congruent because of reflexive property, okay, I now know that angle 1 is less than angle 2 because 10 is smaller than 11. Or you could say angle 2 is greater than angle 1 because 11 is greater than 10. All right. Again, it's not exact numbers right now, but it's at least making a deduction based on what the hinge theorem, okay, based on that hinge theorem. Again, the hinge theorem is the one that allows us to deduce this information. Okay, of course, you got to throw a little algebraic elements into this. Okay, so here I have a side congruent to another side. 15s are congruent. Of course, this side right here is congruent to itself. That's the reflexive property. Okay. Now, again, I don't know the angle measures here. For all we know, before I look at these numbers down here, for all we know, this can be congruent to this. We don't know because there's a variable in there. But based on the fact that we're given these sides, we now know that this side right here it's got to be less than 66 degrees because 10 is less than 13 and all the other sides are congruent. So now I can actually solve, okay, for a possibility. Now again, there are a lot of numbers less than 66, so it's not going to be an equation. It's going to be an inequality. So I'm going to set it up like this. 2x plus 5 is less than 66. I continue to solve. 2x equals 61. Sorry, 2x is less than 61. And then I have x has got to be less than 30.5. So as long as x is less than 30.5, then I know my angle measure is going to be less than 66 degrees. Now, there's a catch to that. Can I have a zero angle measure? Can I have a 0 degree for an angle? No, I cannot. So I have to find another end to that range, just like we did yesterday. There's going to be a range here. So I've got to set this equal and say it's going to be greater, not equal. Set it greater than 0 because I can't have a 0 angle measure. Okay? So when I solve this, I have now 2x plus 5 is greater than 0. I solve this, end up with 2x is greater than negative 5, and then I end up with x is greater than negative 5 halves. Yesterday, or this afternoon, when we were going over the side lengths and stuff like that, we said we can't have a negative number. But that was when we were finding an actual angle measure. And that was when we were finding an actual side length, an actual distance. Here, I'm finding an x value, and this x value can be plugged into here and possibly create a non-negative degree measure. In fact, definitely create a non-negative degree measure. So here's my new range now. Here's my lower and my upper limits, okay? So now I have x is going to be, or negative 5 halves is less than x, which is less than 30.5 or 61 halves, okay? I kept them both as fractions because that's what we, you want to make it uniform there. So negative 5 halves is less than x, which is less than 61.5. Okay, very simple. And again, as always, write down any question you have. Please, please, please bring it to tutoring or ask during class in our moment to ask that. Finally, last but not least, indirect proof. We don't even have to do a whole lot for this. Basically, an indirect proof is using what it is not in order to prove what it is. Okay. Logic puzzles and Sudoku, I don't know how to say that, and process of elimination, those things are the exact, what we're talking about, indirect proofs. For example, when you do those logic puzzles that says, hey, I have Billy and I have Tommy and I have Jeff and I have Steve. One is a football player, one is a basketball player, one is a soccer player, and one is in the band. Okay? So then you do that logic puzzle that says, okay, Billy doesn't like playing sports where he can't use a round ball. Okay, well then that eliminates him from being a football player, right? Okay, so basically we eliminated that and proved that he was not a football player. And as you approve all those one by one, you start to figure out what Billy likes to play because you're proving the other ones to be wrong. And so that's what an indirect proof does. It uses something else to prove, say, hey, he can't do this because he doesn't like this. Since he doesn't like this, he must like that. Okay? So anytime you use process of elimination, that's when you use the indirect proof. Okay? And that's it. So I will see you guys tomorrow. It should be short and sweet. We'll go ahead and start working on the classwork tomorrow, discuss a couple things, grade the homework, work on the classwork, and then start getting ready for our quiz and then our test. Okay, again, have any questions, come see me. Have a great night.